Yeah, good afternoon. So yeah, we will talk about how to use TiDB. But before that, I would like to explain what kind of company we are. So first of all, I want to tell you the company's name. We are Micoworks. So most people in US said Micoworks. And yesterday, one person said, I feel like I know Micoworks, but it's not us. Yeah, we are Micoworks, and we was established around 6 years ago, and we had raised around 20 million US dollars, and our employee is around 100 over, and our business site are Japan, Manila, and Taipei. And our product named Micoworks. So our product is a powerful product from lead nurturing to creation of repeating customers based on the customer data. So the number of our clients are over 1,000, and mostly they are enterprise companies. And our retention rate is 99%. So this is a very quickly demo. So we use Line. Line is like a WhatsApp. So once our brands can connect their end users, and our product can get attribution data or some kind of action data using survey. And our product can make some segmentation and send a personalized message. And this is our business scale. So we are just a startup, but we have already connected to about 40% of Japan's working age populations. And this is our growth speed. So our growth rate is beyond top SaaS performers in US. And the reason why we grow faster is first, we exited 2 other products, and we focusing all on resources on Micoworks. So our growth rate is pretty nice, and especially our net retention dollars is over 150%. Yeah, it's pretty nice. And the other reason is the end of third-party cookies. So maybe you know, without third-party cookies, it's very challenging to keep marketing efficiencies. So most marketers think they need to use a first-party data and social media to make a better marketing efficiency. And in Japan, it's a line, because this number shows that the differences between email or line is 3 times over about a CTR. So it means most marketer needs to and must use line. And our market is so-called the conversational commerce market. And this market is expected to grow up to approximately 290 billion US dollars by 2025. So it's one of the promising markets in the world. And this is a product overview. So as I said earlier, so our brand can connect with their customers using Line, and our product can get some attribution information and action histories. And our product make some segmentation and deliver a meaningful communications for each. Sorry. Oh my God. And this is one example. So this is a top-class travel agency. And after they started to use our product, their daily sales from Line is from 2.3K to 62.5K. And not only that, we provide real-time data from the website integrations. So thanks to that, our brand can automatic clustering and distribution of content with the highest response rate, and it's performed over 649%. And let's talk about the replacement project from my engineers.
I will take the next part from here. Let's talk about the replacement project. Today, this is the agenda of today. And first, I will introduce myself, and then I will explain the background of our project. And I will talk about the challenges that in our development. And with the integration of the TiDB, how we solved it. And last, I will make a short summary. First, who am I? My name is Chen, and our company come from Japan, but I was originally come from China, and I went to Japan in 2005 and as an international student. And since I was graduated, I have been working as a web engineer. And end of the last year, I joined Micoworks as a SRE engineer. And because my career are all about with web development, so all my technical stack and my background are all around with web technologies. And that link is cute, right? Yeah, okay, let's get to the technical parts. First, I will explain the architecture of our system, but because the entire system is quite large, I will focus on the part of our architecture around the database. Before we integrate TiDB, we use three databases in our system. DynamoDB to accumulate the attribute information and action history, and the Redshift to classify the customer segments, and the OLAP RDS to host the master data and for the rest. And you may be wondering that why didn't we just stick with OLAP? The reason is that we accumulate a large amount of the data, and in our system, the customer table has 216 fields to hold the attribute information, and we will accumulate more and more data in future. So, in generally, tuning a database that holds a large amount of data, it's a trade-off necessary. For example, if you want to improve the performance of the search, you may analyze the data and the table, and you put some proper index on tables to make the search become faster. But if you put too many index on it, the performance of update could be decreased. So there is a trade-off. However, our service aims to be the HR #1 marketing platform. So we will achieve the best performance of both the update situation and the search situation. We will not be compromised. So to make it, we try to use DynamoDB and Redshift. I think that most of the attendees today are very familiar with this technology, so I will skip the detailed explanation. But just let me highlight the key point. The DynamoDB is suitable for the large-scale data accumulation, and the Redshift is suitable for large-scale data analytics. And we analyzed our service, our use case. We decided to use the two databases according to their strengths. For the part, we accumulate the data. We expect the high performance and high availability of the DynamoDB could be help us, and we expect the entire system could withstand with a high load of large influx events. On our hand, for the parts that we classify customer segments, we want to use the strength of the data analytics capability of the Redshift. So we can make the search quickly enough for any combination of the attribute and actions. But however, as we started the development with these two databases, actually we encountered several problems. The main one is as follows. First, the problem is the complexity of the system was increased fast. And the next one is we are not able to achieve the performance that we expect of a Redshift. And the last one is the operation was become a little laborious. Let's start with complexity. As we use DynamoDB to accumulate the data, and then we transfer the data to Redshift for the customer segmentation. So we had to perform a synchronization between the DynamoDB and Redshift. You can imagine that if you have only one database in your system, when you want to change a schema, you just to verify and test the schema change and implement it. Perhaps you want to perform a implementation test. Anyway, you are done with this. You are done for the schema change. However, when system has more than one database that need to be synchronized, you have to do all of the work on each database. And as you know, it's time-consuming. Also, the TiDB is a NoSQL database, and Redshift is a SQL database. Some field types are different between them, such like the date, the flag, and some more. So when we synchronize the date, we need to make a value transformation based on the field. And we had to do the maintenance every time we change the schema. And since we have 3 databases in our system, our engineers need to switch them between their mains depending on the date we're operated on. So we want to reduce the workload. We use ORM for the RDS, and we also want to use ORM for Redshift. We tried, but we found out that Redshift is not fully interchangeable with PostgreSQL, so eventually we failed to apply the ORM to Redshift. As a result, raw SQL are used for the Redshift operation. And in our internal security reviews, we found that leads to a potentially SQL injection. So we cost some time to fix that. It's a problem for us. And about the performance of Redshift. And first, I had to say, Redshift is a great database for the data analytics. And we want to get the best performance from Redshift, so we follow certain best practice. And Redshift has some features like query cache and auto analyzer to make the performance very good. However, query cache just speed up the queries execute repeatedly, such like statistics. However, in our use case, we found that the search with different conditions more rare than the repeatedly statistics. So as a result, we cannot be able to utilize the query cache in the most time. And as we continue to accumulate the data in our system, the auto analyzer, which analyze the data and use information to create the optimized execute plan, we found that this feature cannot be optimized on data analytics as quickly as we expect. So as a result, we found this feature may not be match our use case. And there is another thing, the unique constant key. For typical relational database such like MySQL, PostgreSQL, the unique constant key is work like you put the unique key, and when you save date, the database will reject the date if there is some duplicate date. But in Redshift, the unique constant key is just like declaration in the metadata. It's just like the label for mark the data is not duplicated. And actually, Redshift didn't reject the duplicate data. So in our system, we expect what behavior, as I said, but actually we get many duplicate data in our database. So we had to use the materialized views to exclude the data. And this approach indeed affect the performance. And also, Redshift is designed for the data analytics. So it's not suitable for the massive concurrence. In our service, we queried Redshift from kind of service, and once the concurrent correction limit is reached, the entire system was severely impacted. And there's one more case. As I said, our service can perform a search with different conditions with any attribute information and action. But sometimes we found there was some common conditions between search. If we use typical MySQL or PostgreSQL SQL, we can just put some proper index to make the search fast. But this optimizer method applied to Redshift is challenging for us. So overall, we cannot achieve the best performance of Redshift. The part of the reason is that our lacks of the understanding of Redshift. However, we discussed in our team and we concluded that maybe the strength of a Redshift is not good match our service or use case. So that's it. And about the operation, since we have 3 databases, so we had to set up monitoring on each one, and the notification also. And for the development and debug, we synchronize the data from DynamoDB to Redshift. So the data maybe exist in different places. So when the engineers want to investigate something, it became hassle to track the data where it is. But I think it's not a big deal. The really biggest problem for us is the backup and restore. Of course, the DynamoDB could be backed and restored, and the Redshift could be backed and restored. It is fun up to this point. But as we synchronize the data, so the point is, how do we ensure the data consistency when we restore the data from the different database? Actually, we didn't find out how to do this. It's a big problem we need to fix. So this is the challenge that we faced in our development, and we discussed in our team for kind of options, and we come with a conclusion that the TiDB maybe should be the solution for us. So we turn to include integration of the TiDB. And the next part, in the next part, I will talk about how we resolved it. This is the new architecture of the system after we integrated TiDB. You can see the DynamoDB and the Redshift has gone. And the row of the DynamoDB and the row of the Redshift are integrated into the TiDB. So because the DynamoDB and Redshift has removed from our system, the synchronization and the value transformation or hustle workload are removed from our system. I think we have greatly reduced the burden of the engineers. And as TiDB has the compatibility of the MySQL, so as I said, we use the ORM on the Aura RDS, and also we can apply the ORM to the TiDB. With this, we can eliminate the use of the raw SQL. I think it could help us to prevent the SQL injection in our future development. And also, we can use the optimized method like as index, unique, strong key, as we expect to the TiDB. And we are, of course, concerned about the performance. As TiDB is a distributed HTAP database, it means that TiDB can combine the row store, which is TiKV, and the column store, which is TiFlash. And with, we can use the combination to achieve the performance that we expect. For some more detail is that for the part of the, we accumulate the attribute information and action history. The high scalability of the distributed architecture of the TiDB can ensure the great performance of the large influx events. And for part of that, we classify customer segments. The database optimizer could auto-select the better performance path between TiKV and TiFlash. So the combination can ensure the great performance for the search situation. And about the operation, that actually we use the TiDB cloud, so we can get many information from the dashboard of the TiDB cloud, like the resource of the instance, of course, CPU, memory. But also, we can view through queries and the key visualizer in real time, which is very helpful. With this real-time information, our engineers can easily grasp what is happening in just in time. And I want to talk a little more about the key visualizer. The key visualizer shows a heat map of the overall usage of a TiDB. So it means that we can easily find out which table or which state is accessed the most. I think it's very helpful because now we use this key visual to analyze our database and optimize the database. And as TiDB Cloud is a cloud service, so we can easily set up the backup and restore. And because there's only one TiDB, the data consistency is ensured easily. And yeah, this is how we resolve the challenges with the TiDB. But also, TiDB is a new tool for us, so we learned some new expertise from the TiDB. For example, as I said, the database optimizer could auto-select the better performance path between TiKV and TiFlash. But we found out that sometimes with some complex queries, the optimizer maybe do some not so good choice, and we collaborated with the PinCap staff, and it shared information, and they told us why the optimizer could be stupid in some case and how to fix it. By applying their advice, such like the SQL hints, and apply the MPP mode, we can resolve the performance issues or memory issues. And for another case, one day, when there was one service of our system became heavy due to the very large influx events. And we quickly start the investigation, and we also cooperated with PinCap in time. And we checked the key visualizer together, and we found out that is a hot stop issues where the access are concentrated in particular table. And the PinCap offered us advice to optimize the table. And we use this advice. We applied this advice, and we fixed the failure in a few hours. So I think we made a great collaboration with PinCap. and we learned a lot about TiDB from him. So let me make a summarize. So because our service aims to be the Asia #1 marketing platform, so we will achieve the best performance of the update situation, and we will achieve the best performance of the search situation. We won't be compromised. And to make it, we first tried to use DynamoDB and Redshift, but it doesn't work well for us. So the reason is that first the complexity of the system was increased, and we found we cannot be able to achieve the performance that we expect from the Redshift. And so we turned to integrate the TiDB, and the TiDB allowed us to reduce the complexity of the system, and also we can use TiDB to achieve the performance that we expect. And also we then, by using the TiDB, we learned many new expertise from it. And I think we made a good decision to integrate the TiDB, and I'm very proud of our team to perform the replacements in just 1 month for our system. So this is all of my presentation today, of our presentation today. Thank you for your attention.